Welcome back to The Explainer. So today we're tackling a topic that is guaranteed to be awe-inspiring, completely mind-bending, and honestly, a little humbling. We're going to look at the sheer physical scale of our universe. You know, when we look up at the night sky, it's pretty easy to feel small. A clear night reveals thousands of twinkling stars, making us feel like this tiny speck in a grand design. But when you actually map out the true distances, the raw numbers, and the colossal structures lurking out there in the dark, it goes way beyond just feeling small. It completely defies human comprehension. Our brains simply didn't evolve to process distances with so many zeros attached to them.
Okay, let's dive right into this. What if I told you that even traveling at the speed of light, you still couldn't cross the entire universe? Think about that for a second. The absolute fastest speed physically possible in the cosmos, fast enough to circle the Earth 7.5 times in a single second, and it is still not fast enough to see it all? There is no way. This isn't science fiction, it's a cosmic paradox that completely shatters our everyday, earthbound understanding of distance. If the ultimate speed limit of reality still leaves you stranded in your own tiny neighborhood, what does that say about the size of this city?
Which brings us to the central question of this explainer. So, just how big is the universe? It's a question we've been asking since humans first learned to look up. From ancient astronomers mapping constellations, all the way to modern astrophysicists launching multi-billion-dollar telescopes into orbit, we've been trying to find the edge. And the answer we arrive at today might just completely change the way you see reality, your place within it, and what it truly means to be a part of this cosmos. But before we measure it, let's quickly establish our baseline. Section 1. What is the universe? Everything we know and don't know.
Simply put, the universe is everything that exists. All of space, time, galaxies, dark matter, the whole shebang. It contains every star that has ever burned, every black hole devouring light, and the absolute smallest subatomic particles vibrating in the void. But to really grasp its scale, we have to make a very important distinction between two concepts: the observable universe versus the entire universe. The observable universe actually has a measurable size. It's the specific portion of the cosmos we can see from Earth. Because the universe has a finite age and light takes time to travel, light from the absolute most distant regions has only had a certain amount of time to reach our telescopes. We're basically stuck inside a giant visible bubble. On the other hand, we have the entire universe, and scientists don't know for sure how big this is. The physical reality extending beyond our bubble could very well be infinitely large, just going on forever without end, which renders it completely unmeasurable.
So let's look closer at that visible bubble. You might know that the universe is about 13.8 billion years old. So logically, you'd think we can only see light that has traveled for 13.8 billion years, making our bubble exactly 13.8 billion light years in any direction, right? Well, actually scratch that. It's not quite that simple, because space itself has been expanding that entire time. Think of it like a giant sheet of rubber being stretched in all directions. The light that started traveling toward us billions of years ago has literally been stretched along with the very fabric of space. Because of that, our observable bubble actually reaches much further. It stretches about 46.5 billion light-years in every single direction from Earth. That makes the observable universe roughly 93 billion light-years across.
Now, we throw that term around a lot, so let's clarify exactly what a light year is. A light year is incredibly deceptive because the word year makes it sound like a measure of time, but it's actually a measure of physical distance, much like a mile or a kilometer. It's the exact distance that a beam of light, which, by the way, travels at a blistering 300,000 kilometers every single second, can cover in one Earth year. Just to put that staggering speed in perspective, a photon of light can travel from the Earth all the way to the Moon in just about 1.3 seconds.
Now, what's really interesting about this slide is what happens when you do the math on a single light year. The sheer raw number is staggering. It comes out to 9.46 trillion kilometers. In just 1 year, light travels almost 10 trillion kilometers. If you were to hop in a car and drive at highway speeds without ever stopping, it would take you over 10 million years to travel just one single light year. And remember, our observable universe bubble is 93 billion of those light years across.
All right, Section 2, our cosmic address. Let's start right where you are sitting today and take a step-by-step journey outward. First up, we start on Earth, our familiar blue marble, which is part of our solar system. Zoom out, and our entire solar system is just a microscopic speck swirling in the spiral arms of the Milky Way galaxy. Zoom out again, and our massive Milky Way is just one part of a galactic neighborhood called the local group, bound together by gravity.
The local group sits within the massive Virgo supercluster. And if we pull back even further, Virgo is just a tiny branch of the even more colossal Luniakea supercluster, a structure so immense that its name literally means immense heaven in Hawaiian, housing over 100,000 individual galaxies. And finally, all of that sits within the observable universe. The wild thing is, every single step outward on this list is unimaginably larger than the last. It completely dwarfs the previous structure. And this brilliantly illustrates exactly how staggering that zoom out is. Walking entirely around the Earth is about 40,000 kilometers. A huge journey for a person, right? That takes many months of continuous walking. But just the distance to our own moon is 384,400 kilometers. Keep going. The distance from the Sun to the Earth is 150 million kilometers. And yet, if you look at the diameter of just our Milky Way galaxy, we have to throw out kilometers entirely. It's 100,000 light years across. Then we jump to the observable universe at 93 billion light years. The jump in scale here is almost impossible to comprehend. Our brains simply stall out trying to map a leap from millions of kilometers to billions of light years.
And within that massive 93 billion light-year expanse, things get extremely crowded. The observable universe contains an estimated 2 trillion galaxies. To put that into perspective, our home galaxy, the Milky Way, has somewhere between 100 and 400 billion stars. Every single one of those stars could host its own complex planetary system. Now multiply hundreds of billions of stars by 2 trillion other galaxies scattered across the deep field of space. The sheer population of the cosmos is mind-boggling. There are astronomically more stars in the observable universe than there are grains of sand on all the beaches on Earth combined.
Section 3. The vast emptiness. Let's look at the mechanics of the void.
Because despite those trillions of galaxies, space is terrifyingly empty. When we look at the composition of the universe, that tiny slice of normal matter represents every single star, planet, galaxy, and speck of dust we can actually see and interact with, the physical stuff you and I are made of. The vast, overwhelming majority of the universe is actually composed of dark matter and dark energy. These are mysterious, invisible forces that completely dwarf normal matter. Dark matter provides the hidden gravitational glue holding galaxies together, while dark energy is driving the acceleration of the cosmos. We're just a tiny, tiny fraction of what's out there, surrounded by a silent, dominant void we can barely begin to comprehend.
And the situation is actively changing. The universe isn't just big, it's getting bigger every single second. Space itself is expanding, which pushes galaxies away from one another. Think of it like baking a loaf of raisin bread. As the dough rises and expands in the oven, every single raisin moves further away from every other raisin. In the universe, the dough is space itself, and the raisins are the galaxies. And here is the truly wild part. The farther a galaxy is from us, the faster it appears to move away.
Which builds into this tragic consequence. Some galaxies are moving away faster than light can ever catch up. Because it's space itself that is stretching, the cumulative expansion across vast cosmic distances means some distant regions are receding from us faster than the speed of light. Now, this isn't a violation of physics, because the galaxies aren't moving through space faster than light. The space between us is just growing too fast. This means we will probably never reach the edge. Tragically, parts of today's universe will eventually become permanently unreachable, crossing over a cosmic horizon where their light will never ever be able to reach our eyes again.
Section 4. Beyond the horizon, the final frontier.
So we've talked extensively about our visible bubble, but everything beyond that horizon is forever hidden from us. There could be countless more galaxies out there, extending forever, whose light simply hasn't reached Earth yet and maybe never will. But focusing on what we can map within our bubble, we find the largest known structures in existence, which together form what astronomers call the cosmic web. This web is made up of massive galaxy clusters, sprawling superclusters, gigantic threads of gas and galaxies known as cosmic filaments, and they are all separated by massive, desolate voids. It's this sprawling, interconnected network that defines the large-scale structure of our reality. Honestly, it almost resembles the neural pathways of a giant brain stretching across billions of light years.
Let's try to bring all this back down to a human level with an analogy. If the Earth, the entire planet we live on, with all its oceans, continents, and sprawling cities, were reduced to the size of a single grain of sand, the observable universe would still be larger than anything our minds can truly imagine. At this scale, our entire solar system might be the size of a dinner plate, while the Milky Way would cover an entire continent. All of human civilization, all of our history, all our triumphs and struggles, occupies an almost invisible fraction of the cosmos.
So the crucial point is, when you step back and look at the raw facts we've covered today, it is absolutely stunning. The oldest light we can see hitting our telescopes right now is nearly 13.8 billion years old. There are likely hundreds of sextillions of stars glowing out there. Space continues stretching and expanding every single second we speak, and the whole cosmic dance is dominated by mysterious dark matter and dark energy that we don't even fully understand yet.
So, to answer our starting question, just how big is the universe, astronomers can only measure the observable universe, that 93 billion light-year sphere centered around us. The honest answer about the total size of the entire universe is that it remains one of science's greatest mysteries. We know our bubble exists, but the physical reality beyond it could be vastly larger, perhaps 100 times bigger, 1,000,000 times bigger, or maybe even truly infinite, stretching out into eternity with no boundaries at all.
You know, the more we explore space, the more we realize how incredibly small we are. But rather than feeling insignificant, we should feel excited about what else is out there hidden in the dark. What remains to be discovered in that boundless void? If this journey across the cosmos blew your mind today, don't forget to like, subscribe, and turn on notifications for more amazing explainers like this one. See you in the next cosmic adventure!